So here we're being asked to find the second derivative, that's f double prime of x. We need to start off by finding the first derivative. We have a quotient, so we need in quotient rule means we'll need f and g, as well f prime and g prime. F prime, derivative of the top, that's 2, g prime is 1. Like I said, we'll be using quotient rule, so it's f prime g minus g prime f divided by g squared. So the first derivative, f prime g minus g prime f all over g squared. Simplify that a bit. Distribute the 2 and distribute the negative. And combine like terms on the top. And that is our first derivative. To find the second derivative, now we need to deal with the first derivative as our function. So f is going to be negative 3, g is going to be x minus 1 all squared. So then f prime would be 0, g prime, we need to use the chain rule, so the 2 comes down, x minus 1 to the power of 1 times 1, the derivative of the bracket. That's going to work out to 2x minus 2. So then to get the second derivative, again, it's a quotient. So f prime g minus g prime f of the first derivative, the stuff we just did in Greek. So f prime is 0, g is x minus 1 all squared, minus g prime f all over g squared. Simplify that a bit. 0 times x minus 1 all squared is 0. So we have negative times 2x minus 2 times negative 3 works out to 6x minus 6. And on the bottom, we can combine those two exponents, have x minus 1 to the 4th. Now, what is commonly going to happen with quotient rule questions and the second derivative is the top will be factorable. In this case, there's a 6 that's common we can take out, which is actually going to prove quite useful in just a minute. By taking that 6 out on the top, we've created a common factor on the top and the bottom. I can cancel out the x minus 1 on the top with 1 of the x minus 1's on the bottom, leaving me with my final answer 6 over x minus 1 cubed.